Let's clarify Table 220. 19 of the National Electrical Code, specifically regarding whether it includes wire sizing within the demand ratings provided in column C. The answer is no. Table 220. 19 does not explicitly account for wire size when it presents demand ratings. It is important to recognize that for certain specific appliances like household electric ranges, the code requires additional calculation steps not built directly into the table's values. For instance, in the case of a household electric range, a demand factor of 1.25 or 25% is applied to the calculated load. This multiplier is essential for determining the correct wire size and overcurrent protection for the range circuit, but it's not automatically incorporated into Table 220. 19. The rationale behind the separate application lies in the variability of appliance load characteristics. Different appliances and equipment have diverse load profiles and usage patterns. A water heater's demand profile will differ significantly from an air conditioner's, for example. Therefore, a single table, like 220.19, cannot encompass all these variables directly. Instead, the code provides general guidelines and specific adjustments that must be applied in conjunction with the table to accurately determine the circuit requirements. To illustrate, consider a 9 kilowatts 120/240 volts household range. To correctly size the branch circuit, one must first convert the kilowatt rating to amps. This is done by dividing the power in kilowatts by the voltage. Thus, 9 kilowatts divided by 240 volts equals 37.5 amps. This calculation determines the initial current draw of the range. However, code mandates applying the demand factor of 1.25 to account for the potential continuous operation of the range at a high percentage of its rated power. So 37.5 amps multiplied by 1.25 equals 46.875 amps, which is typically rounded up to 47 amps. This 47 amp figure is then used to select the appropriate wire size in accordance with tables like 310.16 and the appropriate overcurrent protection, such as a circuit breaker or fuse. In conclusion, while Table 220.19 simplifies demand calculations for many common circuits, it does not remove the requirement to apply specific demand factors outlined in the code. It is the responsibility of the electrical designer to apply these factors and make sure that both the wire size and the overcurrent protection are appropriately sized to ensure safe and compliant electrical installation. The multiplier for household ranges isn't incorporated into the table because it's not a one-size-fits-all solution. The demand factor for different types of loads can fluctuate depending on conditions such as the occupancy of the building, how the load is used, and the climate or environment it is in.